welcome. So I just want to continue again with doing a few more examples for you just to help you get the hang of how all these things work and all the kind of tricky parts to it. So in the last one, we kind of focused in on transforming, expressions into powers so that you can work with them better, as well as changing the variable. So I'm going to do that again to make sure that this doesn't confuse you when people change the variable. You're going to see me change it a whole bunch of times so that it should feel more natural. One of the things we're going to focus in on here is that particularly as you start learning new techniques, you're going to see a product like this and you're going to want to do something fancy with it. But you could just realize in a case like this, a product like this, just multiply it out. Okay, so that's actually kind of one of the biggest things to focus in on here is to just multiply this out. Before doing that, I'm going to kind of point out something. So 1 over z here is the same thing as z to the minus 1. I am going to want to write it that way because, right, when we multiply when we multiply powers, you want to add the powers, and so I want to be able to see it like that. Otherwise, it might be a little difficult to see what powers I'm actually adding. Okay, so here we go. So this is going to equal the same thing as the integral from 1 to 2. And then I am just going to distribute this out. So I have z squared times, and then I am going to change it to that to make it a little bit easier. And then I can multiply this over here. So I have plus z squared times 2z dz. So all I did was I applied the distributive law. And then here, so when I multiply these, right, I add the powers. So we'll do that. So we have z, and then we have 2 plus minus 1. And then we have here, sometimes it's good to put a parenthesis there so that you understand that all of this is inside of the same integral. And then this is going to be, I'm going to pull the, right, this is a product, so I can pull the 2 to the front of it, and I can write z squared. And then we're going to note for ourselves again, so this is z to the 1. Sometimes it's helpful to kind of write those in like that, so then I can just see that this is z plus 1 dz. Okay, and then I can keep going, so I have the integral from 1 to 2. And then I have z to the 1, so that to me, right, so this is z to the 1. We can emphasize that here. Right? So z to the 1 is the same thing as z. And then here I have z cubed, so that I can leave it like that. Plus 2z cubed dz, and it helps to have worked these things out twice so that I am less likely to make mistakes and confuse you in front of you. Okay, so now we're at a stage where we can actually integrate that. Before, we're just kind of manipulating things around into a way that it's easy for us to integrate. So now we're ready to integrate. And remember, at first we kind of just treat this like we're taking antiderivatives. Again, it might help us to put a 1 here to remember that there's a 1. Because then I can write z to the 1 plus 1 divided by 1 plus 1. And then plus 2, we can just pull that out. And then we have to go z to the 3 plus 1 divided by 3 plus 1. And then we want to close this up. And we don't have to put a plus c there because we have bounds. We put our bounds like that, 1 to 2. Okay. Again, I can pull in a different color. Kind of like the way that orange shows up a little better than the pink, so we'll do that here. This is going to be a 2. This is going to be a 4. This is not squared. I'm just telling you what bounds I'm evaluating at. So then we can go ahead. Well, okay, so then let's clean that up just slightly. So this is going to equal. And then I'm going to have z. So, yeah, okay. So z squared divided by 2 plus that 2. We're multiplying there, so that 2 can just kind of be seen as on the top. Z to the 4th. Divided by 4. It's nice to, before you start plugging things in, get things in as nice, clean of a way of writing them as possible so that we make fewer mistakes when we plug stuff in. Okay, and now we can actually plug things in. But remember, so I find it helpful, of course you don't need to do this, but I find it helpful, is to actually go through and first write this twice with parentheses in it every time I see my variable. So my variable is z, so I put parentheses squared, divided by 2 plus 2 times, And then I have the z to the fourth, so I want to put parentheses to the fourth, and then divide it by 4. So this is the first time I write this, and then I put a minus sign, and then I write the exact same thing again with my parentheses there. And then I put plus 2 parentheses to the fourth divided by 4. Okay? So now I remember, so the first thing I put in is my upper bound, so I put a 2 here, and I put a 2 here. And then over here, then I put in the lower bound there, so I put in a 1, and I put in a 1. Okay? Now I can actually compute these. It might help just to, so if I was computing something like this, I might kind of go through. So this is 4 halves, and I'm just going to see how I did it there. Yeah, this was how I did it. So I did 4 halves. And then this one here, well, I have 2 times, so 2 to the fourth, okay? 2 to the fourth is going to be 16. And then I have a 1/2 here, right? This 2 and this 4 actually give me a 1/2. And I think actually in my notes over there, I did this as a 1/2. It's convenient to clean that up like that. Okay, so this one actually gives me 16 halves. And now I'm going to get minus for each of these because that can distribute through. And so I get a minus 1/2. And again, a minus 1/2. So altogether, those should give me 18 halves. Or 18 divided by 2, which is the same thing as 9. Okay, so to kind of go through this again, what was a little bit tricky, anytime we're going to be dealing with powers, it often helps to write it as the power. So when I have a 1 over z, that's the same thing as z to the minus 1. And then I'm just applying the distributive law. I had to multiply this times this and add that to multiplying this times this. So I do that there. When I have a z to the first power, right, if it's on its own, anytime we have a variable on its own, it's actually taken to the first power, and that helps us there. Because when we multiply, right, the powers add. Okay, and you can pull the 2 out because this is multiplication's commutative. You can switch the order. Okay, and then over here, so 2 plus minus 1, it's easy to mix those up, but let's not mix them up, that it's the same thing as 2 minus 1, which is 1. So that's another z to the 1, or z. Okay, and so here I added the powers, 2 plus 1. Okay. And now I've got this in a form. Again, I want to have that 1 there because when I integrate, it makes it easier again. Because I just want to add 1 to that power and then divide by that new power. Add 1 to the power, divide by the new power. And then in this last step, and so in the notes, I actually cleaned this up to make this 1/2. I didn't do that here. And so, but the way I did it was I took every time I saw the variable, I put it in parentheses, and I did that minus exactly the same thing where every time I saw the variable, I put it parentheses, and then I put in the first set of parentheses, I put the upper, and in the second, I put the lower. And then I just kind of worked through that. So I hope that makes sense. And then we'll try another one. So we're going to have, so this is going to be the fourth problem, right, because there's 2 of these videos. So now I'm going to highlight something a little bit different. So how do we handle this? So we have the integral of w cubed minus w plus 1 over w squared dw. So again, this one looks more confusing than it actually is. Okay. Because dividing by w squared is going to be the same thing as multiplying by w to the minus 2, and then you can just distribute this out like we did in the previous problem. Okay, so I'm going to go ahead and do that. So this is going to equal the integral of w to the minus 2 times, and then this has to be multiplied by, right, because it's below the entire thing, it needs to be multiplied by the entire thing. So this is w cubed minus w plus 1. dw. So all I did was a w squared on the bottom, the same thing as a w to the minus 2 on top, right? When we move an exponent between top and bottom, we switch the sign on it. And then I can keep going, like distributing this out. It might help to remember that this is a 1 here. So I'll just put it there. And then we go ahead and do that. So we get the integral of, and now we're going to go, so w times, right, so we'll multiply the first two. I'm going to do more steps here, I think maybe than I did over there. So we're going to do w to the minus 2 power times w cubed. And then we're going to get a minus, right, so this is, or I could say plus w to the minus 2 times minus w to the 1. And then I add w to the minus 2 times 1 dw. Okay. And then I can keep going. So I'm going to get, now I add the powers here. So this is going to equal the integral of, so I have w to the minus 2 plus 3. I can pull that minus sign out to the front, right? When I multiply a positive and a negative, I get a negative, so that's good. And then I get w to the minus 2 plus 1. And then I can keep going here. So I'm going to get plus, and then, right, multiplying by 1 does nothing. Okay. You can do one more line here. So this is going to equal the integral of, and then I get w to the minus 1. No, I get w to the 1. Right, which is the same thing as, so this is, we can just write these up here. This is a 1. This is a minus 1. And that stays the same. Okay, so this is just w, because it's w to the 1. But we might want to put the 1 in there, even though it doesn't need to be there, because we're going to integrate. And then we're going to want minus w to the minus 1. And that one I'm actually going to write as 1 over w, because we have a special form for that integration. I forgot my nice black towel today. But we have another one. Okay. And then we have from over here, so we have plus w to the minus 2 dw. Okay. And then I can continue on. So this is going to equal, right, so for the first one, I just go w to the 1 plus 1 divided by 1 plus 1. And then for the second one, I actually get minus the natural log of the absolute value of x. Oops, we're not x, we're w. I can make these mistakes too. So we always have to be so careful. Okay, and then we go plus, and then we have 1 over, okay, so we have a minus 2 there. So 1 over minus 2 plus 1. And then we have w to the power of minus 2 plus 1. And then we don't forget our c. So I didn't forget my c, so I'm happy with myself. And then I can kind of clean this up, right? We don't like to leave things like that. We want to remember what powers these are. So this is just going to be w squared divided by 2, or 1/2 times w squared. That's the same thing. And then the natural log of w. This is just one of these ones that you have to remember when it's 1 over w. Like, that's the only one where it's not just adding the powers. And then we have so minus, no, we don't have, yes we do, but let me make it clear why. So we have here, this is going to be minus 1, minus 1, this is the 2. Okay, and so we're going to get here, we're going to get minus, and then we have w to the minus 1. I can choose whether I write that as 1 over w or not. Here, I just write it like that. In the other one, I write it as 1 over w. And again, we don't forget our c. Our final answer should definitely have a c. Okay. So in this one, what I do, so I have, so I just start out, the main tricky piece in this one, other than the fact I keep on changing the variable name on you, just to get you used to that. It shouldn't scare you. is that, right, if I divide by w squared, that's the same thing as multiplying by w to the minus 2, and then I can just distribute this out, and it's totally a power thing that I'm dealing with. As I've been doing for the past few problems, when I have the variable on its own, I like to put a 1 there, so it makes it easier for me to see both how when you multiply powers, right, you have to add. So when I multiply these, I'm going to have to add the powers. Also, when I integrate or differentiate and I want to manipulate the powers, I'm going to want it like that. So I go ahead and do that here. I just distribute. That's how I got down to here. And then I have to multiply these out. And we do that, right, when we multiply two exponents, we add the powers. So I do that. And then I integrate just like normal, remembering that the one tricky power one is when I have 1 over something. So w to the minus 1. And for that one, I need to actually get the natural log of x. Okay, so I hope that makes some sense, and I'll see you in the next lecture.